have our coil, and then if we have the slip rings, continuous rings, and then we have our carbon brushes. So if this is our carbon brush 1, slip ring 1, then we're going to have one of the ends of the coil being soldered. Soldering now is not an alien thing. So if you solder this part of the coil to this other slip ring, then the other part of the coil would go through the slip ring to the other slip ring. So we have a slip ring here. Slip. To slip is to slide. So it slips, the ring slips along the carbon brush, which is connected to a spring, so that there is no much friction. It should be able to go on it comfortably. And then we have our second slip ring 2. Now the coil is soldered on it. And then we have the carbon brush D2 with our tin, and then we have a wire for contacts, and we have our rod. So we can have our bomb here, and then we have one side of the wall to the other side. So she said she has ever tried to start the generator. So when you pull the generator, what happens is that you kick-start the coil. The coil produces the first spark of electricity. That spark starts the engine of the generator. So the engine of the generator starts moving. Now starts being the one that is turning the coil. That's why generators use fuel. So when you pull it, or when you see a guy kicking the motorcycle, or when you see someone trying to start the car engine, the battery just gives you the starting energy. That current starts the engine, and then the dynamo of the engine, as the pistons are going, they turn the dynamo. The dynamo is what gives the electricity to the whole car. If I start my car, remove the battery, I can leave it for you as long as my engine doesn't stop. If I have enough fuel, I can go for a battery, park it there, it keeps running. When I come back, I just go. You will remain with your battery as long as my engine is on all along. So if I pull that string, then I give the coil a force. So assuming our coil is A, B, C, D, that means this side here, if I pull, if this side was to move upwards, this being the force, then the field is this side, our B. So I will have to use, I'm sorry, if you are a left-hander, will not be annoyed with me. Big men use the right. So I have to use Fleming's right hand rule. So this is my thumb, this is my first finger, and this would be my second finger. This would be, I'm just drawing it like this. But if you want, I can do like this. So I can draw the, because I'm a realist, I can draw the little thing that I'm seeing. And then I draw these two fingers here. And then I'll be having the thumb. This is too big. Whatever. So this is the thumb. B is for motion. This is the first finger, so I can use FF for field. So this is for field. And this is second finger, so this is second for current. So I pull, it starts, the field is B is this one, first finger, motion is upward, so the current will be going. Once I get current in one of the sides, I'm done. I can now make it flow, goes here, comes down, goes here, comes in the slip ring, goes here, comes here, goes in the slip ring, and the circuit is complete, and my ball will start like. So half a revolution later, that is when the coil has gone like this. When B is here, when C is here, when D is here, and A has come here. Remember, in DC or CD, the current was going in this direction. Half a revolution later, the current will have to be in this direction because the coil is still rotating in the same direction. So half a revolution later, the currents would reverse because this other side will be here, this other side will be here. Doesn't seem to click in your minds, so I can draw it here. Drawing is not my problem. So I will be able to have the so I want to be careful only on these slip rings. The short slip ring is now on this side. Okay? And now this other side goes through, and the long slip ring here is now the one which is at this point. So I now have carbon brush. Let me keep the carbon brushes on one side. Carbon brush B1, then this is carbon brush B, S2, S1. So I draw my bulb again, and my bulb is here. This one was on the side. Sorry, this one was on the bottom here. And then this one was on the side. This is half a revolution later. So I can rub it here. So with our DCAB, the coil is still moving upwards, downwards here, the north, south, the field is still in this direction, the current is in this direction in the coil, but watch here, this one is going through to the other one. So when the current reaches here, downwards like this, it crosses to the other slip ring, and now the current is in this direction here. Then goes through the ball to this carbon brush 1 to the slip ring, and then it goes back. So it comes like this. Here it was in this direction. Half a revolution later, it is in this direction, and the process will continue. That's the essence of what we call an alternating current generator. So this generator will give us an AC current, meaning that it would be sinusoidal, that at one point you'll be having the current being positive, at another point you'll be having it negative, and then you come back to the same point, the thing continues up to when the generator stops. On the other hand, if it is a DC generator, then we would have to split these two slip rings and make what we call commutators. So I will just draw the portion of the coil. We all know about the other bit. So it will be commutators. After cutting half of the slip rings, and then here we put insulators, and then this one is soldered here, This one is soldered here. This should be circular. It should be a circle that goes, it spins nicely. So you have carbon brush 2 for commutator 2, commutator 1, carbon brush B1, and then we have the contacts, and then we have the ball. One goes down here, another one goes on the side. So what happens? At the beginning, if the coil is going up, the field is in this direction, current will be in this direction, comes back here, goes down, goes up. So half a revolution later, the situation is still the same, only that commutator 2 will be in contact with carbon brush 1, and commutator 1 will be in contact with carbon brush 2. So you will still have the same direction. But so for my shaver, what happens? I instead put here the current and then cause the turning. And then the turning, I can use whatever I want. I can put it in a radio, and then it moves the tape so that the magnetic strip goes on the detector and I start playing the music. Or I can use it on that thing I told you, the shavers, you see, and then because of applying the principle of simple harmonic motion, I start chopping my hair. And that's how the direct current is. So we looked at direct currents. We looked at how we can play around them in terms of being sources, both voltage source and current sources. And then we've looked at the alternating currents and the way we can generate them. So